In late November of 2025, a strange signal began broadcasting from the summit of Mount Rainier. Not an eruption, not a seismic tremor, a steady, rhythmic hum of electronic static that appeared on public monitoring feeds, sending tabloids and online forums into an absolute frenzy. The volcano, they claimed, was waking up. The data was there, a terrifying waveform pulsing from its core, except it wasn't. The signal was traced to a single analog seismic station, St. Andrew's Rock, or STAR. It had accumulated a thick layer of rime ice in the winter cold, and the strange broadcast was nothing more than atmospheric noise. A radio antenna freezing over. The director of the Pacific Northwest Seismic Network, Harold Tobin, had to publicly debunk the story. But here is the detail that tells the real story. While the world was panicking over a frozen antenna, geologists were looking at a far more significant and far more real threat that had unfolded just 4 months earlier. A phenomenon that produced not one spurious signal, but over 1,350 legitimate earthquakes deep inside the mountain. And the strangest part of this story is not that America's most dangerous volcano rumbled. It's what that rumbling told us about the silent, landscape-altering disaster that can happen without any eruption at all. To understand what happened, you have to go back to the summer of 2025. The mountain known in local Salish as Tucuba was quiet. Its normal state is a near-constant geological whisper, generating around 9 to 10 small locatable quakes a month as its internal systems adjust. Then, at 1:29 a.m. Pacific time on July 8th, that whisper became a roar. A swarm of earthquakes began directly beneath the 14,409-foot summit. Harold Tobin and the team at the PNSN watched as the rate of seismicity exploded. It peaked at a staggering 40 quakes per hour. These were not large events. Most were too small for a person to feel, even if they were standing directly on the summit. But their sheer number, their relentless frequency, and their location 2.8 miles beneath the ice were a major signal. The mountain was stretching. Something was moving inside. For weeks, the swarm continued. On July 11th, a magnitude 2.42, the largest of the series, struck. By the time the swarm finally subsided in late August, the official count was over 1,350 locatable earthquakes, with thousands more recorded that were too small to definitively pinpoint. It was the largest and longest earthquake swarm ever recorded at Mount Rainier in modern history. The question on everyone's mind was immediate and primal. Was this the precursor to an eruption? It's a strange thing when the ground beneath you sends up over 1,000 signals in just a few weeks. Curious what you think about this, actually. Have you ever been in an earthquake? Let me know in the comments. This is the part the headlines do not capture. The immediate fear was a repeat of Mount St. Helens, a catastrophic explosion sending a plume of ash into the stratosphere. But for volcanologists, the first priority is diagnosis. An earthquake swarm is a symptom, not a disease. And to understand the cause, you have to test the mountain's breath. On August 18, 2025, scientists from the Cascades Volcano Observatory, or CVO, conducted an airborne gas-sniffing flight directly over the summit crater. They were hunting for two specific molecules, sulfur dioxide, SO2, and hydrogen sulfide, H2S. These are the telltale signatures of fresh, rising magma nearing the surface. The flight found water vapor. It found low-temperature carbon dioxide. It found absolutely zero magmatic gas. The check engine light was on, but the fuel wasn't the problem. Dr. Alex Yezi, a geophysicist at the CVO, analyzed the seismoacoustic signals. The character of the quakes themselves told the same story. These were brittle, sharp fractures of rock under stress. They were not the low-frequency, fluid-filled tremors associated with magma pushing its way upwards. The swarm, in other words, was not magmatic. It was hydrothermal. Now, here's the part nobody is putting on the news. To say the swarm was hydrothermal is scientifically accurate, but it hides the terrifying reality of what that actually means for a volcano like Rainier. You have to understand the mountain's internal structure. Mount Rainier is not a solid cone of rock. Its core has been cooked by geothermal heat for millennia. This process, called hydrothermal alteration, has slowly turned solid, stable rock into a weak, crumbly clay. Trapped within this weakened rock is a massive plumbing system of superheated water and steam, some of it reaching 180 degrees Fahrenheit, circulating under immense pressure. The 2025 swarm wasn't lava moving. It was this high-pressure water blasting its way through the cracks and faults in the rotten core of the volcano, fracturing rock as it went. The mountain wasn't preparing to erupt. It was boiling itself from the inside out. By August 25th, the USGS officially declared the swarm over. The seismicity had returned to its baseline whisper. And yet, for the scientists who study Rainier, the event was a profound confirmation of their deepest fear. Because the number one danger at Mount Rainier is not an explosive eruption. It is a catastrophic collapse. The mountain is mantled by 25 major glaciers, holding more ice and snow than all other Cascade volcanoes combined. The combination of a structurally weak, clay-like core and a massive heavy ice cap creates the perfect condition for the deadliest weapon in Rainier's arsenal, a lahar. A lahar is not a flood. It is not an avalanche. It is a flow of volcanic debris that moves like wet concrete but at the speed of a car on a highway. Imagine the entire ice cap flash melted by a hot rock slide. That water instantly mixes with the rotten clay-like rock of the mountain itself, creating a slurry so dense it can carry house-sized boulders for miles. It doesn't flow around obstacles. It removes them. Historic lahars from Rainier have traveled at 45 to 50 miles per hour down the very same river valleys that are now densely populated. When confined in those valleys, the flows have been measured at over 100 feet deep. The swarm of 2025 was a reminder that the hydrothermal system is active, that the mountain's core is weak, and that the trigger for a lahar doesn't have to be a magmatic eruption. It can be a simple, non-eruptive collapse of hydrothermally weakened rock under the weight of its own ice. This is called a Case 1 lahar. It can happen on a clear, quiet day. And this is why Mount Rainier is designated a decade volcano, and why it is ranked as the most dangerous volcano in the United States. Not because of its explosive potential, but because over 150,000 people live and work directly on top of the deposits from its ancient lahar flows. And then there is the existential question buried in the rings of dead trees. For decades, the worst-case non-eruptive scenario was a theory, a model based on geological deposits. Then, in December of 2025, a scientific paper published in the journal Geology provided the smoking gun. It was a master prehistoric mudflow known as the electron mudflow. Geologists knew it was one of the largest lahars from Rainier in the last millennium. They knew it had roared 60 kilometers down the Puyallup River drainage. What they didn't know was its precise trigger or its exact date. To find out, they became forensic botanists. Deep in the forests along the Puyallup River, they hunted for ghost forests, stands of ancient trees that were buried and killed by the mudflow centuries ago. They found what they were looking for, preserved under feet of lahar deposit. They took core samples from these dead trees and from living, old-growth trees nearby. Using a technique called dendrochronology, or tree ring dating, they could match the ring patterns year by year between the living and the dead. This allowed them to pinpoint the exact year the buried trees died. But they went further. Using radiocarbon dating on the outermost ring, the last year of the tree's life, and a statistical method called wiggle matching, they could narrow it down not just to a year, but to a season. The result was definitive. The electron mudflow happened in the late summer of the year 1507 CE. And the tree rings showed no evidence of a volcanic blast, no sudden climate shift from an ash cloud. The evidence was clear. The largest lahar of the last 500 years was a Case 1 event, a spontaneous collapse. The mountain simply fell apart, sending a devastating flow into the valley with no warning. This is the kind of deep dive we do on this channel. We don't just cover the what, we dig into the how and the why. If you want more videos that connect modern events to this kind of forgotten history, you can subscribe. It helps us keep making them. What the 1507 discovery proves is that the homes, schools, and businesses in the towns of Ording, Sumner, and Puyallup are all built on top of a landscape shaped by this exact type of event. The very ground beneath them is the 500-year-old deposit of the electron mudflow. The modern lahar warning system in Pierce County is one of the most advanced in the world, a network of acoustic flow monitors designed to detect the ground-shaking rumble of a lahar and trigger sirens. But the physics are unforgiving. Even with instant detection, a lahar traveling at 45 miles per hour gives communities like Ording as little as 40 minutes to evacuate, 150,000 people needing to get to high ground in less than an hour. The 2025 swarm served as a wake-up call, not because it signaled an eruption, but because it highlighted the need for better monitoring of the very phenomena that could trigger a collapse. In direct response, Harold Tobin's team at the PNSN moved aggressively. That August, while the swarm was still tapering off, they drove up a remote forest road and installed a brand new high-tech seismic station on a peak called Burley Mountain. Its location was chosen specifically to create a better triangulation network with existing stations, allowing for quicker and more precise locating of the shallow quakes that could signal instability on the mountain's flanks. That data now feeds directly into the public shake alert system, a tiny but crucial improvement in the race against time. The sheer volume of the 2025 data was, for most people, incomprehensible. A list of 1,350 dates and magnitudes is just noise. This is where a geology professor from Central Washington University, named Walter Seliga, had a moment of creative genius. To help the public visualize, or rather experience the event, he fed the seismic data from the swarm into a program that translated it into sound. Each earthquake became a single piano note. The magnitude of the quake determined the note's pitch and volume. The time between quakes determined the silence between notes. The result is an ambient, haunting piece of piano music. It begins with a flurry of notes, a chaotic cascade representing the peak of the swarm on July 8th, before slowly over the course of several minutes, becoming sparser with longer and longer pauses, until it fades back into the single, occasional notes of the mountain's background seismicity. Listening to it, you can hear the mountain stretch and settle. You can hear the tension building, and you can hear it release. It is a strangely beautiful and deeply unsettling way to comprehend the scale of what was happening, unseen, deep beneath the ice. So, Lake Jackson in Florida drains, and the story is about the water moving. Mount Rainier shakes, and the story is about the rock that is no longer stable. In both cases, the visible event is just a symptom of a larger, invisible process. For all the focus on the dramatic 2025 swarm, the most dangerous part of Mount Rainier remains its quiet, steady-state condition. Scott Beeson, the park geologist for Mount Rainier National Park, spends his days monitoring this relentless, slow-motion decay. He tracks the retreat of glaciers, which can destabilize the slopes they once buttressed. He maps the paths of minor debris flows, the small-scale cousins of a lahar, that happen almost every year. He observes the steam vents, or fumaroles, at the summit, which create a complex network of ice caves even in the dead of winter, a visible sign of the heat engine still running within. This is the daily reality of managing a volcano that is actively rotting from the inside. The panic over the frozen star antenna in November 2025 shows how quickly misinformation can spread, how eager we are to see a dramatic, explosive threat. It's a strange thing to live on top of what is essentially a geological time bomb. Maybe send this video to a friend who lives in the Pacific Northwest, because the real threat is quieter and in many ways much harder to prepare for. The Osceola mudflow, which occurred about 5,600 years ago, was an order of magnitude larger than the electron. It involved the collapse of the entire eastern flank of the summit, removing 3 cubic kilometers of rock and burying an area that extends all the way to modern-day Puget Sound. The deposits from that single event form the ground on which thousands of people live today. This is the geologic inheritance of the region. The 2025 swarm did not trigger a collapse. The mountain held. But each swarm, each hydrothermal pulse, is another stress test on a system that is fundamentally weakened. It is another reminder that the internal plumbing is active and capable of generating immense pressure, Harold Tobin put it best, reflecting on the event. There was never any sign that it was getting close to an eruption or anything, he said. But we had to assess that, and we recognized that our network of seismometers could be higher density. It is the classic paradox of disaster preparedness. You spend millions to install equipment you hope will never be used. You plan for an event you pray never happens. The new station at Burley Mountain is a direct result of this thinking, a quiet investment born from a loud summer. The story of the swarm is a story of scientific response, of moving from alarm to diagnosis to action. It is about deploying airborne sensors to sniff for gas, geophysicists like Alex Iezzi deciphering the language of the waveforms, and network directors like Harold Tobin calmly communicating the nuanced threat to a worried public. It's also about a deeper history, one read in the bark of 500-year-old dead trees, that tells us the monster in the backyard doesn't always roar before it attacks. The electron mudflow of 1507 is now the benchmark. For a worst-case, non-eruptive scenario, it is the ghost that haunts every emergency plan in Pierce County. The fact that it happened in the late summer, a time when glacial melt is already high, adds another layer of concern. It confirms that massive lahars can be born from the mountain itself, with no help from magma. So 3 questions now hang over the Cascade Range. How much pressure can the hydrothermally altered rock inside Mount Rainier withstand before another section gives way? Why is a hydrothermal swarm, in its own way, more unsettling than a magmatic one? A sign of decay rather than aggression. And what does it mean to live in the shadow of a volcano whose greatest danger is not the fire within, but the water and rock it wears like a crown? The swarm of 2025 is over. The mountain is quiet again, whispering its 10 or so quakes a month. But deep inside, 2.8 miles below the summit glaciers, the water is still hot, the rock is still weak. The hydrothermal system is, right now, somewhere beneath the ice and snow, continuing its slow, inexorable work of dissolving the mountain from the inside out. The pressure is still building. The clock is still ticking. And somewhere down in the Puyallup Valley, on ground that was once the top of a mountain, 150,000 people are going about their day.